Good morning to all of you. Today, our subject is engineering thermodynamics. The topic is second law of thermodynamics. Very important chapter, second law of thermodynamics. So, before discussing going to second law, I will discuss what is thermal reservoir, what is source, what is sink, what is heat engine, what is refrigerator, and what is the heat pump. Clear? So just I will tell you, explain all details. Then I will start what is Kelvin Planck statement, what is Clausius statement, then do some problems. Right? Now, first what is thermal reservoir? Thermal reservoir. It is a large heat capacity which can exchange heat with the system. Clear? So, the system which can give heat, which can take heat. One is called source, and is called sink. What is source? Source means high temperature. Sink means low temperature. Clear? A source is a high temperature reservoir which can give heat. This can give heat. A sink is a low temperature thermal reservoir which can take heat. This can take heat. Clear? So thermal reservoir means it is a high heat capacity. When you transfer some heat to the reservoir or from the reservoir, this will not affect the thermal reservoir. So this includes source and a sink. What is source? Source is a high temperature reservoir, high temperature. Clear? Which can supply heat. But sink is a low temperature reservoir which can take heat. Clear? So then I will discuss what is heat engine, heat pump, refrigerator. First, write the definition of thermal reservoir, source and sink. Now, a thermal reservoir is that part of an environment. A thermal reservoir is that part of environment which can exchange heat energy with the system. Clear? It has sufficiently large heat capacity and its temperature is not affected by the quantity of heat transferred to or from it. Clear? It is characterized by the temperature which remains constant. The heat can transfer is very slow. So this is quasi-static. Clear? So when it is transferred to the reservoir or from the reservoir, it will not affect its heat. Clear? So then I will discuss what is source, what is the sink. Source, this is source, high temperature. Source means high temperature. This is a source. It can supply heat to this high temperature reservoir which can supply heat. Sink, this is sink. Low temperature. This can take heat. A sink can take heat. Q. Clear? So source is a source is a high temperature reservoir. High temperature reservoir which can supply heat. Which can supply heat. Clear? Examples are boiler furnace. Boiler furnace, nuclear reactor. Nuclear reactor, etc. Or combustion chamber, etc. Clear? This can supply it. It is sufficiently large heat capacity which can supply it. Examples are boiler furnace, nuclear reactor, combustion chamber. This is the example of source. What is sink? Sink means low temperature. It can take heat. This gives heat, but that takes heat. Sink. A sink is a low temperature reservoir. Low temperature reservoir which can take heat or receive heat. Receive heat. Clear? What is the example of sink? Atmospheric air, atmosphere. Examples are atmosphere, ocean, river, etc. These are example of sink. Now, by using source and sink, I will explain you what is heat engine, refrigerator, and a heat pump. Right? Heat engine, refrigerator, and a heat pump. First, I will discover what is heat engine. Heat engine. Clear? This is heat engine. This is source. This is sink. Right? This is heat engine. Source, sink. Source is high temperature. Source is high temperature. Sink is low temperature. Clear? So this is T1, heat supply Q1, doing some work W, rejected to sink Q2. Clear? The heat engine takes heat Q1 from source, doing some work, then supply heat Q2 to the sink. So what is Q1 is equal to double plus Q2. What double is equal to Q1 minus Q2. Right? Q1 is equal to double. Suppose 10 kJ of heat is supplied to the engine from source. 6 kJ of heat is done by work. Rest 4 kJ is supplied to the sink. Clear? So Q1 is equal to double plus Q2, or double is equal to Q1 minus Q2. Clear? Now I will explain. I will write the definition. A heat engine is a device which is used to produce work from heat. Clear? It can produce work from heat when operating in a cyclic device. Clear? Both heat and work interactions take place. Clear? Heat engine is a device which is used to produce work continuously, or for continuous production of work from heat when operating in a cyclic device. Both work and heat interactions. Both work and heat interactions takes place in a heat engine. Clear? It is characterized by following features. What features? Receive Q1 from the source, doing some work, reject Q2 to the sink. Clear? Let Q1 is equal to heat supplied from source Q1. Q2 is equal to heat rejected to the sink. What is Q1? Heat supply from source. What is Q2? Heat rejected to the sink. W is equal to work output. What W is equal to? Q1 minus Q2. Q1 minus Q2. Let T1 is equal to temperature of source T1. T2 is equal to temperature of sink. Clear? The efficiency of heat engine, the efficiency of heat engine is defined as the ratio of work output to the heat supplied, right? That is eta thermal or eta engine is equal to double by Q1. Double means Q1 minus Q2 by Q1 or 1 minus Q2 by Q1. Clear? This is efficiency of heat engine. In case of reversible heat engine, Q1 by Q1 is equal to Q2 by Q2, right? Q1 heat supplied from source, T1 temperature of source, Q2 heat ejected to sink, T2 is equal to temperature of sink, T1 temperature of source, T2 temperature of sink, Q1 heat supplied to heat engine, Q2 heat ejected from the heat engine. So, in case of reverse heat engine, Q1 by T1 is equal to Q2 by T2. So, what is heat engine is equal to? T1 minus T2 by T1 or 1 minus T2 by T1. Fair. This is about heat engine. Next, refrigerator. Next, refrigerator. Clear? What is refrigerator? Suppose this is a room. Try to understand the room. The room has temperature 10 degrees centigrade. Clear? Outside surrounding is suppose 30 degrees centigrade. Clear? Suppose this is 20 degrees centigrade. This is 40 degrees centigrade. Clear? Now, this room is to maintain at 20 degrees centigrade. But outside temperature is 40 degrees centigrade. So heat, this is high temperature, clear? This is low temperature. So when the roof is heated, when the wall is heated, the temperature transfers from outside to inside. So the temperature 28 centigrade will not maintain, it may rise. 20, 21, 22, 23, it may rise in this way. But our ambition is to maintain the room at 22 centigrade. This is low temperature. So to maintain 20 centigrade, the heat which is transferred to the room will be pulled out from the room, will be transferred from the room with help of a machine that is called refrigerator. Refrigerator, AC machine, refrigerator. Clear? Its main function is to remove heat from the room, which is low temperature, and throw to the surrounding, which is high temperature. Clear? So its function is to receive heat, to remove heat from the room, which is already cold, than the outside temperature. This is refrigerator. Or what is a heat pump? Suppose this is a room. Clear? Suppose its temperature is 20 centigrade. And outside is suppose 0 centigrade or 5 centigrade. Clear? This is summer condition. This usually is summer. This usually winter. Clear? So this is room. The temperature is suppose 20 centigrade. The outside temperature is 5 centigrade. Now this is today condition is today temperature outside temperature lower than the our room temperature. But since the room is 28 centigrade, the heat can transfer from room to outside from the roof, or it can be lost due to outside surrounding. Clear? Our roof is cold, our walls are also in cool surface, so this heat may be rejected, lost. This heat may be lost, but transferred from inside to outside. Clear? But in this way, to maintain the room at 20 centigrade, so heat will be transferred from outside to inside with the help of a device that is called heat pump. Suppose the heat pump is placed here. Heat pump. Its function is to transfer heat, to extract heat from the low body. This is low temperature. This is high temperature. Clear? So the heat pump main function is to extract heat from low temperature from outside and transfer it to the room, which is high temperature. Clear? Both are same function. Both are extract heat from low through to the high. But a refrigerator function is to cool the room and heat pump function is to heat the room. Clear? So both are reversed heat engine. Reversed means working in backward direction. A heat engine supply heat from the source, heat input, work output, doing some work. But here, heat output, work input. Clear? Now, I will write definition of refrigerator, heat pump, its coefficient of performance. This coefficient of performance clearly I will understand you, make you understand, right? Now first we will discuss what is a refrigerator. Now this refrigerator, this is space to be cooled, this is surrounding. Clear? This is space to be cooled, this is surrounding. Clear? This temperature T2, this is Q2, work input WR, this is Q1, this is P1. Right? This surround temperature T1, this room temperature T2, this is Q2, work refrigerator, heat supply, heats thrown to the surrounding Q1. Right? Now, what is refrigerator? A refrigerator is a refrigerator is a reversed heat engine. Reversed heat engine. Clear? What reversed heat engine? What reversed heat engine? Reversed means operating backwards. That means the direction of this means the direction of work and heat interaction are opposite to that of heat engine, to that of heat engine. Clear? Its heat and work interactions are opposite to that of a heat engine. Now, its main purpose is to remove heat from the cooled space and transfer to the hot surface. The main purpose of refrigerator is to remove heat from the cold space, from the cold space, and to transfer it to the hot surface, to the hot surface. Clear? Its desired effect, main purpose, its desired effect is transfer heat to extract heat or remove heat extract heat Q2 from the cold body, from the cold body or from the room. Here, its desired effect is the amount of heat Q2 extracted from the cold body. Clear? The coefficient of performance, the coefficient of performance is defined as the ratio of its desired effect, its desired effect to the work input, to the work input, that is COP is equal to desired effect by work input, that is COP R is equal to refrigerator, that is COP R is equal to what desired effect Q2 by W, right? This is coefficient of performance of refrigerator. Now what is Q2 is equal to? Q2 is equal to amount of heat extracted Q2 from the cold surface, right? This is Q2. What is it? W. Now here Q1 is equal to W plus Q2. So W is equal to Q1 minus Q2. What is Q1 is equal to? Q1 is equal to heat transferred to the surrounding, Q1, right? But W is equal to work input, power input, work input. W is equal to work input. What W is equal to? Q1 minus Q2. Put here value of W. Now COPR is equal to, COPR is equal to Q2 by W, means Q2 by Q1 minus Q2. This is COP in terms of heat and work. So in terms of temperature, means for reversal machine, COPR is equal to T2 by Q1 minus T2. This is for reversal machine. Clear? For reversal refrigerator. This is for reversible machine. Q1 by T1 is equal to Q2 by T2. Clear? Means I can put T2, T1 in place of Q2, Q1. So COPR is equal to T2 by T1 minus T2. This is for refrigerator. Now heat pump. Now heat pump. Heat pump. This heat pump this is outside temperature surrounding. This is heat pump. Room to be heated. Room to be heated. Right? Now the temperature T2. This is temperature T2. The heat started from the outside Q2. The WP work input heat supplied to the room Q1. This temperature Q1. Right? This is heat pump. Heat extracted Q2 from the outside surface, which is temperature T2, doing some work input, then transfer it Q1 to the room, which is at temperature T1. Clear? The heat pump is also a reversed heat engine. Reversed heat engine means the direction of this is operating backwards. Which means the direction of heat and work are opposite to that of heat engine. Clear? That of a heat engine. But the function of refrigerator heat pump are same. That function is to extract heat from cold body and throw to the hot body. This function is also to extract heat from the outside cold surface and throw to the heated room surface. But the desired effect of refrigerator is to cool the room. But the desired effect of heat pump is to heat the room. Clear? The amount of heat Q2 extracted from the room, Q2 is the desired effect for refrigerator. But in case of heat pump, the amount of heat Q1 which is supplied to the room to be heated is the desired effect. Right? The desired effect of heat pump is the amount of heat Q1 supplied to the room. Clear? Here, outside is cool surface. This is cool surface. This is heated surface or hot surface. Room to heated. This is high temperature. This is low temperature. This is high temperature. Clear? Generally, in the winter season, outside temperature is less than the inside temperature. Clear? Our room temperature is more than outside temperature. So, when we are going to outside in winter, we are wearing sweaters. But in case of summer season, the room temperature is lower than outside temperature. Clear? So, the function of refrigerator is to extract heat from the room low temperature through to the outside surface high temperature. In case of heat pump, also the same function to extract heat from the low temperature outside through to the high temperature room. But the desired effect of refrigerator is to cool the room, and the desired effect of heat pump is to heat the room. Clear? Its desired effect is Q2, but heat pump desired effect is the amount of heat extracted from the room, the amount of heat supplied to the room, Q1. Clear? The desired effect of the heat pump is the amount of heat Q1 supplied to the room. The coefficient of performance, the coefficient of performance of a heat pump is the ratio of its desired effect to the work input. Clear? That is COP pump is equal to desired effect by work input. Clear? That is COP pump is equal to Q1 by W. Q1 by W. So what is W is equal to? Q1 is equal to WP plus Q2. So WP is equal to Q1 minus Q2. Right? WP. This is equal to Q1 by Q1 minus Q2. Where where Q1 is equal to heat supply supply supplied to the room Q1. Q2 is equal to heat extracted from outside. W work input for work done. What W is equal to Q1 minus Q2. Right? For reverse heat pump, for a reversal machine or heat pump or refrigerator or heat engine or reversal machine, Q1 by Q1 is equal to Q2 by Q2. So what is COP of pump is equal to Q1 by Q1 minus T2. T1 by T1 minus T2. This is for pump. Now, COP of pump is equal to Q1 by Q1 minus Q2 minus 1 plus 1. I will make minus 1 plus 1. Clear? So this make this 1. So what is COP of pump is equal to LCM Q1 minus Q2 Q1 minus Q1 minus Q2 plus 1. Clear? So this is equal to COP of pump is equal to Q1 minus Q1 plus Q2 by Q1 minus Q2 plus 1 minus Q1. Clear? Q1 Q1 cancel out. So what is COP of pump is equal to hence COP of pump is equal to Q2 by Q1 minus Q2 plus 1. What is this? COPR. This is equal to COPR plus 1. Hence, COP of pump is equal to 1 plus COPR or COP of R plus 1. Hence, the COP of pump machine exceeds the COP of a refrigerator by 1 by unity when operating in case of pump, in case of a refrigerator. Clear? So when operating a pump, for the same machine, its COP exceeds 1 when operating that machine as a refrigerator. Clear? Hence, the COP of a pump exceeds the COP of refrigerator. The COP of refrigerator by unity by 1. Right? When operating same machine, when COP of pump operates in a machine, its COP When a pump operates in machine, its COP exceeds by 1 when the same machine operating as a refrigerator. Clear? Now, today I will do some problems relating to heat pump, refrigerator and heat engine. Right? Last class, I had done the problems for steady flow energy equation. Today, I will start problems for second law thermodynamics. Before doing second law, I have already explained you what is heat engine, what is heat pump, what is refrigerator. Now, I will do some small problems, short problems regarding this theory. Then, I will do Clausius statement, Kelvin-Planck statement, then do long type problems. Clear? Now, the question is, a heat engine produces work equivalent to 80 kilowatt work output, heat engine, with a thermal efficiency of 40%, eta thermal. Find heat transfer rate to and from the engine. Third, draw the figure. This is heat engine. This is sink. This is source. Clear? This is source. This is sink. Temperature T1, T2, Q1, double engine, Q2. Right? So, now write the given data. Heat engine produces work equivalent to 80 kilowatt. W is equal to 80 kilowatt. W is equal to 80 kilowatt. And thermal efficiency is work output. Work output. W is equal to 80 kilowatt. Clear? Thermal efficiency. Thermal efficiency. Eta thermal is equal to 40%. Means 0.40. Now, what is heat? This heat engine. Q1 is equal to amount of heat transfer to the engine. Q2 is equal to amount of heat transfer from the engine. It supplied, it rejected. Right? Q1 is equal to heat transferred to the engine. Q2 is equal to heat transferred from the engine. From the engine. Now, what eta is equal to, eta thermal is equal to work output by heat input. Heat input, that is W by Q1. Right. So what is eta? 0.40 is equal to 80 by Q1. So what is Q1 is equal to 80 by 0.4. 80 by 4 by 10. 800 by 4. 200. What is Q1 is equal to 200 kilowatt. Is answer for heat transfer to the engine. Now Q2 from the engine. Again W is equal to Q1 minus Q2. What is Q1 is Q2 is equal to Q1 minus W. 200 minus W means 80. Clear? 120 kilowatt. This is Q2. Heat supplied to the engine Q1, heat rejected from the engine Q2. Right. Next question number 66. Number 66. These are short questions. 6 mark questions these are. Right. This is question number 66. The question is 80 develops 10 kilowatt power, resisting heat at rate of 2 to 5 kg per minute. This is question number 66. The question is 80 engine develops 10 kilowatt power when receiving heat at the rate of 2 to 50 kJ per minute. Find the amount of heat rejection from the heat engine and the thermal efficiency. Clear? This is heat engine. Here, this is source. This is sink. This is source. This is sink. This is temperature Q1. Heat received from source Q1. Doing some work W. Transfer. Reject Q2. Temperature T2. Right. The question is heat engine develops 10 kilowatt power. W is equal to 10 kilowatt. Receives heat at the rate of 2 to 50 kJ per minute. Q1 is equal to 2 to 50 kJ per minute. Means 2 to 50 by 60 kJ per second. Right. This is equal to तीन 75 by 2, 37.5. This is Q1 is equal to 37.5 kilojoule per second kilowatt. Right. This is kilowatt. This is kilowatt. Now what is Q2? What is efficiency? Let Qt is equal to heat rejected from the engine. Eta thermal is equal to eta engine is equal to thermal efficiency. Thermal efficiency of heat engine. Now, what is eta thermal is equal to? What is W is equal to? Q1 minus Q2. Right? This implies Qt is equal to Q1 minus W. What is Q1? 37.5 W 10. What is Q2 is equal to 27.5 kilowatt. This is Q2. Answer. Now, efficiency. Efficient engine is equal to WQ1 10 by 37.5. Right? This may be 0.26666, that is 26.66%. This is heat rejected from the engine. This is efficiency of heat engine. Now, next class I will do some problems relating to refrigerator heat pump. Then I will start what is Calvin-Planck statement, what is Clausius statement. Thank you. Next class I will do all the problems. Thank you. Make all likes and subscribe to our channel. Thank you.